Now, one of the type of diagrams was really useful is what we call a Venn diagram, and they become useful when we've got non-mutually exclusive events occurring. So, because we have a possible overlap of outcomes, what we want to do is make sure we get those outcomes correct. So, we've got first example here of 25 music students and 19 play piano and 19 play violin. Now, the first thing we look at and go, well, 25, but we've got 16 and 19. Wait on, that's more than 25. So it's obvious that some play both piano and violin. So that's going to be part of the problem. Usually it's, and you can see in part C, what's the probability that the selected student will play both instruments? Well, we need to work out how many do play both instruments there. So this is where a Venn diagram comes into play. So what we've got, a Venn diagram is, we've got a box around it, and then we've got two overlapping circles. You can have 3 overlapping circles or 4 overlapping circles. Depends on how many different scenarios you have with this, with the different options here. So how do we work out how many people play both? Well, the idea there is that if we have the addition there and take away how many students we know we have, we would get an overlap of 10 there, because that's 35 together, but there's only 25, so 10 must have been counted twice. So what we do is that's what we put in our overlap of our two ovals here. So 10 people are in the middle. They belong to both sets, both the piano and the violin set, because they're both two separate sets. So 10 people are in both, but that means if there's 16 play piano, then there must be 6 that just play piano by themselves, and there must be 9 play violin by themselves, because 19 play violin. So what's the probability then that a student chosen at random from this class will only play piano? Well, there's 6 that only play piano out of the 25. So there's our probability. And our probability that we get someone playing both, well, 10 out of 25, which is 2/5 of a chance. So that's how we set up our Venn diagram. This time we've got 30 students, 12 study physics, 14 with chemistry, and 19 study neither. 9 study neither. Which again, 12, 14, 9. Well, again, we've got too many than the 30 students in the class. So if one student is selected, find the probability of both physics and chemistry. Well, the idea we get one doing both. Notice we had the box around our probability before about our Venn diagrams. That's because we really need the box, because it's enclosing everything. But if something's not enclosed in the two ovals or circles we've got, then we need to still keep it enclosed. And this is where the neither section. So they're not belonging to either set. They're outside both sets. Well, we said 9 study neither physics or chemistry in this one. So there's our 9 there, which left 21 that must study physics and chemistry, but 26 people all up. So 5 there must be doubled up. So there's how many we have in the middle of the two sets. So 5 there, which means there's 7 just doing physics and 9 doing chemistry by itself, because 5 and 9 is 14, 5 and 7 is 12. So we can see how our numbers match up. They do both. Well, there's 5 out of the 30, which is 1/6. And chemistry only. Well, there's 9 out of the 30, which means it's 3 out of 10. Here's one where we looked out some similar to what we did before, but this time with a Venn diagram. Find the probability out of 10 cards of getting an odd number or a multiple of 3. So an odd, that is or a multiple of 3 there. Well, what have we got? Well, there's 4 that fit into neither of these sets. So, but there's 2 that fit into both, 3 that are odd, 1 that's a multiple of, and 1 just as a multiple of 3. So here's our idea here, where we have 5 out of 10 that are odd, 3 out of 10 that are multiples of 3. But see how we've identified how many we've doubled up. And that's why we take the 2 away, gives us 3/5 there. So that's how we're able to work that out using those ideas. And this is showing us where we can get a good idea of how we've doubled up on some elements in our sample space when we are doing some problems that are non-mutually exclusive.